Okay, this will be a quick video just on the beginning of section 3.1 so that tomorrow we can finish up 3.1 um, and then we won't have as much to do tomorrow. So I just wanted to do a quick recap on exponents. So for this first problem right here, when you're multiplying exponents, you could certainly write it out the long way. So we've got x to the third, which would be x multiplied by itself 3 times. And then we've got x to the fourth, which would be x multiplied by itself 4 times. And then we would ask ourselves, how many x's do we have? And we've got a total of 7 x's. So the much faster way to write this would just be to say that this equals x to the 7th. And the general rule says that, oh, we can just add our exponents together. So we can add the 3 and the 4. Sorry, that's a little bit messy. I'm trying to record this, but my pen's not working, so I kind of have to do it using my trackpad, which is a little bit tricky. So anyway, we would add those exponents. We would get x to the 7th. Kind of the opposite of multiplying is dividing. So imagine you have 5 x's on the top and you've got 3 x's on the bottom. You can cancel 3 x's from top and bottom, and you would be just left with 2 x's, so x squared. And the quick rule would be you can subtract those exponents. 5 minus 3 is 2. Hopping over here, if you've got multiple things inside parentheses raised to a power, each thing gets raised to the 5th power. So we would have 2 to the 5th, and we would have x to the 5th. And then I would say to write that out so that your final answer, you actually figure out what 2 to the 5th is. So 2 to the 5th is 32. So we would have 32x to the 5th. Sorry, again, my writing is a little hard to read. Here, when you've got a power to another power, this would be like writing x squared out 8 times. So x squared times x squared times x squared and so on. The quicker way is to just multiply your exponents. So 2 times 8, and you'd get 16. So x to the 16th would be your answer there. This number 7 is similar to number 5. So whenever you've got something in parentheses raised to a power, each thing gets raised to the power. So the x on top gets raised to the 3rd, and the 2 on the bottom also gets raised to the 3rd. And then you can evaluate that and kind of finalize your answer. So we have x to the 3rd on top, and then on the bottom, 2 to the 3rd is 8. Number 4 over here, anything to the 0 power is just a 1. And then x to the negative 2, if you have a negative exponent, if the negative exponent is on top of the fraction, you can move that whole term down to the bottom. And when you move it down, technically there would be a 1 on top. When you move this x squared, I shouldn't circle it like that. Let me try to be a little bit more clear. I'm going to circle the whole thing. I don't want you thinking that you're only bringing the exponent down. So this whole term, the whole thing that's being raised to a negative power, gets moved down to the bottom. And when you move it down to the bottom, the exponent will turn positive. Same idea would hold if you had a negative exponent on the bottom. So let's pretend I had like y squared divided by x to the negative 3rd. So we're only going to move the things that have negative exponents. So the y squared is fine. It's got a positive exponent. But it's this x to the negative 3rd that needs to get moved up. So the y squared is fine. You just keep the y squared where it is, up on top. Now that x to the negative 3rd gets moved up, and when you move it, the exponent turns positive. So it would be y squared times x to the 3rd. And technically both of those are on top. So if you want to put them over 1, you can. Now what I want to move on to is graphing. If you're told to graph exponents, which you will be told in your homework tonight, I think the quickest way is to just make an XY table. So pick values of X, you can pick some negatives, you can pick some positives, pick a 0. So I would say, like going from negative 2 to positive 2 would probably be good enough. Okay, so plug those in. 3 to the negative 2, that's like 1 over 3 squared. So you're going to get 1 over 9. 3 to the negative 1, that's the same thing as 1 over 3 to the first. So you're going to get 1 over 3, 1/3. Anything to the 0 power is 1. So 3 to the 0 is 1. 3 to the first is 3. And then 3 squared, you'll get 9. Okay, so then you just graph those points. Now on my graph, I'm not going to be able to fit all of them, but let's try our best. So negative 2, 1/9, negative 1, 1/3, 0, 1, 1/3, and then 2, 9 would be up way too far. Maybe I'll make these dots a little bit bolder. All right, so if we connect the dots, it is never going to go below the x-axis. So it's going to kind of skim along the x-axis, and then it's going to just take off and grow really quickly up there. So there is an asymptote on the x-axis. So this never touches the x-axis. It gets really close to it, but it never actually touches it. So our asymptote is at y equals 0. And then if we think about our domain is everything that x is allowed to be. This goes on forever to the left, and it's going to go on forever up and to the right. So it goes forever to the left, forever to the right. The domain would be all real numbers. The range, though, are our y values. So there's no y values down here, and it's everything above that asymptote. So x would have to be greater than 0. It cannot equal 0 because there's an asymptote there, but it can be everything above 0. So that would be an example of exponential growth. If we were going to do an example of exponential decay, again, I would just make an XY table. I would pick values of x. So again, usually pick some negatives, some positives, 0 in there. Okay, so if you plug these in, just be a little bit careful about your negative signs. They're going to kind of try to trick you. So for example, here when we plug in a negative 2, see how it's a negative x? So I have a negative, and then I'm plugging in a negative 2. So really I've got 2 to the positive 2, which would be a 4. Same thing happens here. I've got 2 to the negative x. Well, x is a negative 1. So I've got 2 to the first, which is just 2. And then the next one is 2 to the 0, which is 1. And then we're going to have 2. Now remember, it's a negative x. So it'd be to the negative x, which is a 1. So that's 2 to the negative first, which is 1/2. And then here it would be 2 to the negative, and we're plugging in a 2. So 2 to the negative 2 would be 1 over 2 squared, which is 4. Okay, so let's graph this now. Negative 2, positive 4. Make my dots a little bit bigger. And then negative 1, 2, 0, 1, 1, 1/2, 2, 1/4. Okay, so if we graph this, now it's decreasing, and it kind of comes decreasing quickly, and then it's going to just kind of skim along the x-axis. It's never going to actually touch the x-axis because there's an asymptote there. So again, we've got an asymptote along the x-axis, and that asymptote is again at y equals 0. Domain, you're going to the left, up, yes, but you're also going to the left, and then you're going to the right for forever. So the domain, again, is all real numbers, just like the problem above. And the range, again, there's no y values down here. You only have y values above the asymptote. So our domain, our range would be y greater than 0. And I just noticed I made a mistake. Up here, I had an x. I should have had a y. Anytime you're talking about range, you need to be talking about your y values. I said y, but I wrote x, I believe. So these y values have to be above the asymptote. Now, you can shift these graphs left, right, up, down. You can flip them, you can stretch them. All of the same stuff we've learned before. So if I was graphing, I would want to pick out the parent function, and I would just make an XY table for the parent function only. I'm going to type that because it'll be faster. Oops. Make an XY table for parent function only. Then do your transformations. Okay, so if I'm looking at all three of these examples, I notice that they are all 3 to the power of something involving x. So I would suggest making an XY table. And it doesn't matter if your XY table is vertical or horizontal, it doesn't matter. Make an XY table for 3 to the x. Whoa! Because that's the parent function. They all have a 3, they all are being raised to the x. So let's plug in some values, make a quick table. Hopefully you could do this faster than me because I'm doing this without an actual pen. Okay, so 3 to the negative 2 is 1 over 3 squared, so 1 over 9. 3 to the negative 1 is 1 over 3 to the first, which is 1/3. 3 to the 0 is 1. 3 to the first is 3. 3 squared is 9. Okay, start with that parent function. So, kind of get the general idea here. Now, this is not our final answer, so I would recommend that you kind of make this dashed. And then what we're going to do is we're going to take this function and we're going to shift it. All right, so that's the general idea. And remember, we've got an asymptote along the x-axis. That's how all parent functions start. There's an asymptote along the x-axis for the parent functions. Okay, now for this function, what does that plus 1 do? Well, it's within the function, so that's going to shift it up, down, left, or right. What do you think? If it's within the function, it's going to go left or right, and it's going to be opposite of what you think. So this is a plus 1, so that means it's actually going to go to the left one. So you're just going to take all your points and you're going to shift them all to the left one. So this dot is going to go to the left one, and this is going to go to the left one, left one, left one. Skim along the x-axis and then go up. Now that line is a little bit too thick, so I'm going to make it actually a little thinner, because otherwise you won't be able to see my points. Okay, The asymptote would shift 1 as well. So imagine taking that horizontal line and just shifting it to the left one. It's going to stay where it's at. Next graph. This -2 is outside of the function. Here was the parent function. It's outside, so that's going to actually shift it down. So we're going to shift every point on the parent function, the blue one. We're going to shift every one of those down 2. So here's going down 2, down 2, down 2, down 2. Should make those bigger. And then even the asymptote is going to get shifted down too. So I would recommend that you draw in the asymptote first before you draw in your curve so that you don't cross over it accidentally. So you should be skimming along the asymptote and then increasing up. See, if you start with your parent function, you only have to make one XY table. If you didn't do it this way with the shifting, you'd be making an XY table for all 3 of these. So it's much easier to just make one XY table and then do your transformations. All right, this last one, you've got a -1 within the function, so that goes left or right, opposite of what you think. So a -1 would actually make it go to the right one. And don't forget about that negative sign out in front. Jeez, I can't even read that. I'm going to type it. Oh boy. All right, so this is going to the right one. And then that negative sign out in front, that is a flip. And do you remember over which axis? It's a flip over the x-axis. When it's out in front of the function, that's a flip over the x-axis. If it was inside parentheses within the function, that would be flip over the y-axis. Always do your flips first. Write that down. Always flip first. Okay, so we are going to flip first and then we're going to shift to the right one. So my original blue function, if I were to flip, hang on one sec. All right, if I were to flip this over the x-axis, it would be right there. This flipped over the x-axis, flipped over the x-axis. Instead of going up 3, we'd be going down 3. And then imagine it would be decreasing down like that. But we have to now go to the right one. So this is now, maybe I'll make it even bigger. Whoa, that's too big. Still too big. Oh my gosh. Well, sorry guys. Okay, shift this to the right one. Shift that one to the right one. This is going to go to the right one. That's going to go to the right one. And now connect your dots. Skim along the asymptote. And then it'll go down like that. So for these, the only time the asymptote's going to move is if you're shifting up or down, because it's a horizontal line. So the only way that that's going to move is if you're going up or down. So that's how you're going to do your homework tonight. On the homework, it says for these problems, don't follow the book's instructions. You're going to graph the parent function and then do your shifting. So just like I did these problems right here. Graph the parent function, and the parent function should be dashed because it's not your final answer. Excuse me. And then do your shifting. Excuse me. Okay, last thing to talk about. If you see a problem with E is just a number. E is an approximate 2.71828, 1828, etc. It's irrational. It's like pi. E is not a variable. It actually stands for a number, just like pi does. It comes from this idea right here, 1 plus 1 over x to the x. As x gets bigger and bigger and bigger, this overall number is going to get closer and closer and closer to this number. You don't really need to know that. I just want you to realize that it's a number between 2 and 3, and it's closer to 3. So if I was to graph 2 to the x, that's blue, 3 to the x is black, e to the x, well, 2.7 is closer to 3 than it is to 2. So this is like saying 2.7 to the x. Let me type it out. So this is the red is gonna be closer to the black because it's closer to 3. So if you are told to graph e to the x, you can do that. I mean, if you made an XY table and you plugged in, let's say you plugged in a 0, well, e to the 0 is 1. Anything to the 0 is 1. If you plug in a 1, e to the first is e, so like 2.71828. You could plug a 2 in, just use your calculator, do e to the second. You could plug a -1 in, use your calculator, do e to the -1. You can do e to the -2. They're going to be decimals, but you can still graph them. Okay, that's it. So here is your homework for tonight. And I want to be able to not have to go back over all this stuff tomorrow. I want to continue on with the 3.1 notes. Okay, thank you for bearing with me with the pen situation. All right, good night or good afternoon, whatever. It's good night for me because it's Sunday night. All right, bye.